I am R. Prabha, Assistant Professor in the Department of ECE, SNS College of Technology. In this video, we will discuss the topic on antenna fundamentals for the course Antennas and Wave Propagation. Let us discuss the video topic. So, before going to see the fundamentals, first we should know what is an antenna. An antenna can be defined in many ways. So, the first definition of an antenna is it is a way of converting the guided waves present in a waveguide or feeder cable or a transmission line into radio waves which is traveling in free space, or it may be vice versa. So, an antenna is a passive structure that serves as a transition between a transmission line and the free space used to transmit and or receive electromagnetic waves. Or otherwise, antenna can be defined as it is a converter which converts electrons to photons of electromagnetic energy, and because of this reason it is called as a transducer which interfaces a circuit and free space. So, the picture represents the antenna structure connected in both the transmitting side and also the receiving side. So, at the transmitting side, antenna is connected with the transmission line, and the transmission line is connected to a source or generator which generates or transmits a signal. So, after generation of signals, it will be guided through a transmission line, and here the role of the antenna is to convert a transmission line into free space wave, and this is at the transmitting side. And at the receiving side, the antenna is a device which is converting a free space wave into the guided wave which is given to a transmission line, and it is fed to the receiver at the receiving side. So, an antenna is a transition device between a guided wave and a free space wave. And now we are going to see the antenna types. There are several antenna types based on different parameters. So, some of the classifications given here are end-fire antenna, loop antenna, dipole antenna, stub antenna, slot antenna, and aperture antenna, and also its various classifications. And an important property and important antenna type is isotropic antenna. And this isotropic antenna is a hypothetical antenna, not exist in real life, because it is used only for measuring bar for real antenna and its characteristics. And it is a point source which occupies a very small space and has no directional preference. Its pattern is a sphere pattern, and it has the area as 4 pi steradians. Here the steradian is a unit which measures the radiation angle. And there are different types of radiators are available. One is called isotropic radiator, as we discussed already. It is a hypothetical lossless antenna having equal radiation in all directions. And next comes omnidirectional radiator. Here the antenna having an essentially non-directional pattern in a given plane and a directional pattern in any orthogonal plane. And the third category is the directional radiator. Here an antenna having the property of radiating or receiving more effectively in some directions and than the others. Usually the maximum directivity is significantly greater than that of a half-wave dipole. So, now you can see a horn antenna. So, this is one of the antenna, and a speciality of this antenna is it is a microwave antenna, so which works in microwave frequencies. And now activity. So, next comes the antenna parameters. So, in this section we are going to discuss the different fundamental parameters which measures the efficiency of the antenna. So, one is the radiation intensity. So, the radiation intensity is a very important property of antenna which gives the power per unit solid angle radiated in this direction by the antenna, and it is given by the letter U, and it is equal to r square PR. So here PR is the pointing vector. We know pointing vector is gives the power density and it also gives the power flow of electromagnetic wave, and it is given by the formula 1 by 2 real part of E cross H star, watts per meter square. And here E is the electric field intensity, H is magnetic field intensity. Here H star represents the complex conjugate of magnetic field intensity. So, and the another important parameter is the radiation pattern. So, the radiation pattern is a three-dimensional graphical representation in far field radiation properties of an antenna, and it is the function of space coordinates. So, the far field region is a region which is far distance from the given antenna, and it is independent of the distance from the antenna, and it is measured so there are two types of antennas measured in two planes. One is called E plane and another one is called H plane. And this is the example radiation pattern, and here the center lobe is the major lobe which gives the maximum radiation direction, and other than the major lobe all the other lobes are called as side lobes. So in the side lobes we have back lobes and also the minor lobes. So here the back lobes, minor lobes are representing the power loss in unwanted direction. So for very many important application, it is considered it should be eliminated. And the important parameters in antenna radiation pattern is, one is half power beam width, which is the beam width or angular width between two half power points. The half power point is the point where the antenna radiation power is 1 by half, so it is called as half power. And in between the two half power points of the major lobe, if we calculate the angular width, it gives the half power beam width. And also another type of beam width is called beam width between first nulls. So in between first two nulls is the point of zero radiation, and in between the two nulls, if you measure the angular width, it is called as first null beam width. So next parameter is the directivity. It is also a very important parameter, and it is given by the ratio of maximum power density to average power density in the far field of the antenna. And antenna, another parameter is called gain. So in electromagnetics, the power gain, or it is simply called as gain, is a key performance parameter which combines both the directivity and also the antenna efficiency. So in a transmitting antenna, the gain describes how well the antenna converts the input power into radiated waves headed in a specified direction. And as a receiving antenna, the gain describes how well the antenna converts the radiated waves from a specified direction into electrical power. When no direction is specified, gain refers to the peak value of the gain. The radiation pattern is the polar of the gain, and it is the function of direction. And it is the plot which gives the radiation with respect to direction. And gain is related to directivity as by the formula as G is equal to K into D. So here K is the dimensionless antenna efficiency factor. It lies between 0 to 1, and if eta gain value is equal to 1, and it is a lossless antenna, and always gain is less than the directivity. And there are two types of gains. One is called antenna power gain given by GP, and another one is antenna directive gain given by GD. And the last parameter we are discussing is bandwidth. Bandwidth is another fundamental parameter of the antenna. It describes the range of frequencies that the antenna can correctly radiate or receive energy. And the required bandwidth is one of the parameters used to select the antenna type. Now, the assessment unit of radiation intensity is there are 4 options are given. The answer is watts per unit solid angle. And the second question, the radiation lobe containing the direction of maximum radiation is called as, we know it is a major lobe. Thank you.